Okay. So, do you guys remember what it means if two things are independent?
The probability of one of them happening doesn't affect the probability of the other.
Okay. The probability of one happening doesn't affect the other. I like the way you put that. Okay. Mutually exclusive is a completely different thing. Mutually exclusive simply means that two events are mutually exclusive if they can't happen at the same time. Okay. So, have you seen pictures like this before? What's that called?
A contrast and compare diagram.
Oh, a lot of people call it a contrast and a compare diagram. That's true. It's also got another fancy name,
Venn
a
diagram.
Venn diagram. And for example, stuff happening over here, stuff happening over there. So let's say that this side is evens, and this side is greater than 4, and we're rolling a die. Evens are 2, 4, and 6, right? And what's greater than 4? 5 and 6. Okay, so I'm going to put 5 here. And 2 over here. Where should 4 go?
On the left.
Mm-hmm. And where does 6 go? Yes, because 6 is an even, but it's also greater than 4. So those two things are not mutually exclusive because they can happen at the same time. Okay? So if something's mutually exclusive, it looks like this. This would be something like odds and evens on a die. If you have one chance to roll a number, you can't roll an even and an odd at the same time. Now, it seems like the word not mutually exclusive would be the one that they're separated, but mutually exclusive actually means that they can't happen at the same time. Think about it like, have you ever heard of being exclusive with somebody you're dating? That means that you're only going to date them. That means you're not dating anyone else, right? You're exclusive. So those are separate. All right, example 1A. Are these mutually exclusive or not? Rolling a 3 on a die, rolling a 4 on a die. Can you do that at the same moment in time? Nope, you can't do it at the same moment in time. So what do I call that then? Do I call it mutually exclusive or not mutually exclusive?
Mutually exclusive.
Mm-hmm. Can't do them at the same time, it's mutually exclusive. All right, if I go to a college and I randomly select a student, what are the chances I would randomly select a male student or randomly select a nursing major student? Can those happen at the same time? Sure, you could pick a guy that happens to be a nursing major, so this is not mutually exclusive. All right, talk to your partner about example 1B. Sorry, this should not say this here. Should just say C and D on it. All right, talk to your partner. Gotta join a group, Jessica. So sorry.
What does it mean, a face card?
Yeah.
A face card is a card with a face. So kings, queens, and jacks are all face cards.
I would say because of that counts as a face card. Both of them use it once, so not mutually exclusive.
All right, so both of these are not mutually exclusive. Something that people want to do, and you're gonna want to do this in your homework, is say, ooh, the first one's mutually exclusive and the second one's not, but really it's like, it's a relationship, right? It's how they relate to each other, so together they're not mutually exclusive. It's like if I went up to a couple walking down the street and I said, are you dating? And they're either gonna say yes together or no together. You really hope that one of them won't say yes and the other will say no, right? Like it's a relationship. Is there a relationship or is there not? The reason why these are both not mutually exclusive is because you could select a female that has type O blood, and a jack is a face card, right? So if you pick a jack, you did pick a face card. Everybody okay with this? Okay. The addition rule. The addition rule says that if it's an or question, you take the probability of A, you add it to probability of B, and you subtract the overlap. And I'll explain that in a minute, but for right now, write it. So what does it mean when you see and in a probability question? Multiply. You take the probability of A and you multiply it by the probability of B. But if you see or, it's adding. Probability of A plus the probability of B minus the overlap.